I'm Lucas Cavalcanti. I am a distinguished software engineer at Nubank, and I am a senior architect as well. Nubank uses Clojure as their main backend language. We also use for scripts, like using Babashka and stuff. We use it for like a description language for our infrastructure as well. We don't operate in any like framework or any way. Like most of all the code is written in plain Clojure.
My name is Edward Wible. I was a co-founder of Nubank back in 2013. I was the first technical hire and became Nubank's first CTO, and today I'm a distinguished engineer at Nubank. So back in 2013, before we started coding at Nubank, I was studying and thinking about how we wanted to build the bank. We knew that it was either going to be big as a retail bank, or we would die trying because we really wouldn't make it if we ended up being a small niche sort of a bank with our business model. And the Out of the Tarpit paper was specifically talking about large systems and the sources of complexity and the difficulties that come with scaling large systems. And they really highlighted that mutable state and side effects are the source of most of the accidental complexity in large systems, and that managing that complexity through functional programming techniques, immutable data, and keeping side effects at the edges rather than in the middle were effective techniques at managing that and mitigating that complexity over time. I went looking for sort of real-world applications of this idea, and directly led me to Datomic. I think the thing that the paper left me wondering is, what about the database? Because there's state in the database, the state must evolve over time. How can you have an immutable database? It didn't even make sense to me what the term meant, and that brought me to Datomic, which was marketing itself as an immutable database. And what that means is not that things don't change, it's that you don't lose the history of the prior states of things as they change over time. And for a bank with audit requirements, with regulatory requirements, this ability to maybe go back in time and look at the state as it evolved and look at immutable snapshots of that over time, that just looked like an unbelievable superpower and something that no bank built on legacy technology would be able to have and offer to engineers, building and debugging, nor to customers and regulators and other stakeholders, depending on that system to be correct. So we started writing certain things in Ruby. I think Ruby was the language that we were more familiar with as a founding team, but it also had some scaling issues, some performance issues, the famous global interpreter lock, and also the library ecosystem around Ruby was not as mature.
My previous experiences were on Java and Ruby, in which the code base ages like milk. Pretty quickly, you reach into a point that adding new features starts to get harder and harder, to a point that we just call the software legacy and rewriting to something else, or like just create a competing system.
Looking at Clojure, built on top of the JVM, being able to access the entire Java ecosystem of mature libraries was really, really valuable, especially for building something large at scale. Having to roll all of your own libraries to do basic things would have been an unbelievable detour from our core mission, which was building the business, not building libraries or languages. So it was one of those sort of batteries included things that we just didn't spend a lot of time worrying about the language, the technology, the dependencies, the performance. It all just kind of worked so that we could focus on the business problem that we were solving as opposed to the accidental complexity of the tech stack.